Welcome back to the shop. We're back in the shop today, continuing from last video. I got the boost buck converter in for dealing with the backup camera shutoff problem. So let's take a look at what that little thing is and I'll show you what it does. All right, here we have the device. This is known as a buck boost converter or boost buck converter. It basically combines two DC devices, a boost converter and a buck converter, and it's essentially a switch mode power supply. I mean, the architectures are all different, but most of them are like switch mode power supplies. It's got 4 wires, 2 input wires that you bring power into, and then 2 output wires. And if we look on the little data thing here, I don't know if you can see that, but basically the input is rated, well, I'll start with the output. The output is rated to deliver 10 amps maximum. They obviously come in all different sizes. This one delivers 10 amps at 12 volts with an input that can vary from 8 volts to 40 volts. So what this thing does is it uses inductance and capacitance, and like a switch mode power supply does in your sensitive electronics. It has a transistor that it drives with, likely a microcontroller, and it switches that transistor on and off at a frequency that either boosts the voltage or bucks the voltage, pulls it down to maintain this stable output with a varying input. So if your input is dirty or has transients, then this is a device that will stabilize that. It's just a little circuit board. This one's potted. Nothing's free in physics, so it's gonna, in order to do this stabilization, it's gonna cost you a little bit of heat and power dissipation. So that's why this whole thing is built like a heat sink. But I'm gonna get it hooked up to my DC power supply here and multimeter, and I'll show you what it does. All right, so we're all hooked up here. I have my DC power supply plugged into the input side, and my multimeter, which is like simulating the load, receiving the stabilized power from the device. And right now, we're showing 12.3 on the output, close to 12 on the power supply, but this power supply lets me vary the voltage. So, if I pull this down to as low as 8 volts, the device is still outputting at 12 volts. So it's boosting the 8 volts with, clever circuitry using inductance and capacitance within, as long as you're drawing current within its range, then it will boost the voltage up. And then if you swing the other way, I'm up to 25 volts. We're still down at 12 volts. Now, one thing you might notice, I said before, nothing's free in physics. The multimeter is a load on the device, but it doesn't draw much current in order to read the voltage. The input resistance of these is low. Even if you pull that off, you'll see that the power supply is showing that we're sinking a little bit of power, and that's just the price that you have to pay in electronics to have to do anything. Anything of value, any work that's being done, usually costs you some power. So this device claims to be greater than 90% efficient. I'm not gonna worry about measuring that or anything, obviously, but you will sink some power, just a little bit of power though. We're showing 0.1 watts. Quite small amount of power, but it does cost something. So anyway, that's what this thing does. If you're paying attention, in the last video I mentioned that I'm dealing with a problem with the backup camera on the Buggy periodically shutting off, and I'm suspecting that it might be due to voltage transients. So let's get this all wired in, hooked up, and then see if it's all helps solve the problem. right, we're all wired in, everything's plugged in and ready to go for a test. Let's say I have the backup camera. You know, all the electronics is obviously still blown apart, but everything's plugged in. The device is sitting down there. Backup camera's plugged in through the device. I got the camera dark right now so you can see the screen. So notice I just turned the camera on. You can see the screen there. I'm gonna start the engine up and then run the rear stereo, play around with electronics to make, you know, transients show up and then see if it turns on and shuts off. It's obviously gonna be super loud, but so that's why I'm recording this ahead of time. So that's what you're about to see. I'll even start with it turned on. Excellent. So there you see, staying on. It's looking real good. All right, I thought I'd show another demonstration of how this thing works. Now this is after I already filmed the segment out in the shop and after I already installed it. This is like the next day. I was looking at the footage and playing around with my oscilloscope and I figured this might be a cool way to see it too. So I have another one of these converters sitting here, which is why the other one's already installed. This one's actually a bigger one. I bought a couple of different sizes for different, you know, messing around with different stuff. But what you're seeing is the same voltage DC power supply in the background putting out right now 14 volts. And what this device is in front here is an oscilloscope. You're seeing channel 1, which is the yellow line, is connected to the input of the device or the output of the power supply, and then the output of the device is the blue line. The scale is 2 volts per division, so every one of these horizontal lines, you probably can't see that on the display very well, but is 2 volts. So we're looking at, you know, down at 0 and then up at like 20 volts in this range. So right now we're at 14 volts output, and then of course the device puts out a constant 12 volts, so that's why the yellow line is above the blue line by a couple of volts. So what I'm going to do now is the same thing I did out in the shop, is just jump this thing around. The oscilloscope shows the changes over time. So as you see, you know, I can go, now the yellow line is below the blue line because we're dipping below 12 volts. And then I can go up above the line, you know, a significant margin even within the range of this device, which is up to 40 volts. You know, I can jump around a lot. I'm just cranking the knob back and forth. You know, this is simulating, you know, if your power supply is really dirty and has lots and lots of transients, big jumps or dips, we can see the performance of this device keeps the output voltage constant.
and that's the blue line. All right, it's a new day. Backup camera update. Yesterday, after I got everything all installed, wired, you saw me test the backup camera. Everything seemed to be working fine. It wasn't shutting off. I took the Buggy for a drive and started it up. It was immediately doing what it was doing before, where it was shutting off. So I have a new theory. I came to the conclusion yesterday, kind of frustrated, came to the conclusion yesterday that, well, actually, let me back up. Yesterday I did a bunch more testing after that happened, and I went so far as to, I bypassed the device, I bypassed everything, so the buck boost converter wasn't involved. I had it hooked up and not, tested it both ways, but I got to the point where I disconnected the Buggy's wiring entirely. I had the battery disconnect off, and I had my DC power supply hooked up directly to the backup camera, sitting in place, and it would still occasionally shut off. So that tells me that it's not the Buggy's wiring side of it that is a problem. So I came to the conclusion yesterday that, oh, here's the other thing. The other thing that I got it to do, I couldn't reliably get it to shut off. And then eventually I got to the point where I would hook it off, I would turn it on with or without the boost buck converter, and it would stay on. I couldn't get it to shut off inadvertently. But here's the other thing. None of the buttons would work. So all the buttons on the thing stopped working. So I got to but it would register a click when you touch the button. It would beep, they're like touch sensitive buttons, capacitive or whatever. So they were doing something. The screen was registering the button click, but it wasn't doing anything. So I came to the conclusion, like, maybe this backup camera is just junk. Started shopping for new backup cameras, and I was reading the manual because one of the backup cameras had like the user manual as one of the images. So I was reading the manual, and it says about these trigger wires. Most of these backup cameras come with little trigger wires that you can hook up to a reverse light, so they come on when you shift into reverse, like the way backup camera, the factory backup cameras work. So, but it said, and this was a different manufacturer. It said in this user manual, it said, don't hook up the trigger wire to constant power, otherwise you won't be able to turn the backup camera off, but the buttons will stop working. So now the gears are turning in my head. Now the user manual that came with mine said nothing about this. It's half-assed documentation that didn't explain any of this. And matter of fact, their instructions don't even match the wiring harness that it came with. Like it says, hook up, the red wire to power and the black wire to ground. Well, there is no red wire on their wiring harness. It's yellow. So the instructions are all wrong, basically. They came with mine, but now this is my new theory, which I'm about to test. That's what we're going to do today. My new theory is those trigger wires. I want the backup camera to be on all the time. So those trigger wires right now I have not hooked up. They're just taped off, which the instructions for the other backup camera says you can do that. You can just leave them. It says leave them blank, which is poor wording, but just leave them. So, but what I'm thinking is, in the particular backup camera that I have, they're probably floating, which in electronics means that whatever sensor or microcontroller wiring in there is picking up voltage on that line doesn't have a pull-up or pull-down resistor in the switching circuitry. So what that means is if it's floating, if that wire picks up any bit of transient electromagnetic interference, I'm thinking it's causing it to trigger. So I'm thinking the shutting off and turning on is not the whole device shutting off and turning on. It's the trigger wire turning the camera on and off, as if the reverse wire inadvertently. And what got me thinking is that very particular wording in the other manual that said the buttons will stop working if the reverse is triggered. So if that's it, then what I'm going to do is I'll decide play around with it and decide which way I want it to go. But I just want the camera to be on all the time, and I don't even really care if the buttons don't work after I got everything all set up. It'd probably be better, really, because then you couldn't monkey around and script the settings in the thing. So I'll probably either pull the reverse wire to positive all the time, so it's in backup camera mode all the time when it's, you know, I'll wire that to the switch, or pull it to ground so it won't float the way it is. So I'm gonna get out the power probe, which is another handy tool to have for automotive electronics, and we'll experiment with these wires a little bit today. So stick around and follow me through the troubleshooting process. All right, so I got all this blown apart again. So we have these 3 wires. These are the trigger wires for the 3 channels, which, by the way, the user manual doesn't even mention that channel 1 even has a trigger. It says, you know, connect channel 1 if you want it to be on all the time. It's like, well, channel 1 has a trigger too. So anyway, you can tell I'm frustrated. That's hooked up. Camera's on. I still can't get the buttons to work, but I got my power probe here, and let me set up the tripod, and I'll show you what I got going. All right, so this tool here is a power probe. It's basically a test light. It's like a new version of a test light. It's connected to the battery with these long leads, and it's got this probe, and when you touch the probe to things, this light here turns green if we're reading a positive ground, or it turns green if we're reading ground, like a solid ground reference, because this has a ground and a power reference. So it turns green if we're showing ground, it turns red if we're showing power, and it's just nothing like this when it's floating, basically. So you probably can't see that far down in there, but when I touch it to the transfer case, the light turns on. I don't know. Let me actually, I got this little alligator clip just so you can see what it does. So the transfer case is part of the engine ground, or is grounded by the engine. You can see the light turning on and off as I touch this to the transfer case. All right, so so the first thing, just probing these 3 wires, these 3 trigger wires, I get nothing, which means they are floating. If there was a pull-up resistor in this, pull-up or pull-down resistor in this circuit, I'd be able to read something on here, but the fact that they're nothing. But watch what happens if all I do is probe these wires. So I'm not even applying anything to it, but if I just start touching these wires, the camera turns off. See that? Can you see that on there? Yeah, you can. So I'm doing nothing but just touching to these wires. And then we're seeing kind of the behavior of what it was doing. It would shut off, it would turn back on. It would shut off, it would turn back on. So now I had these wires taped off, so it's not like they were getting continuity. You know, they weren't flying and touching anything, but that just shows you kind of the floating behavior of this thing. If these wires pick up any electromagnetic interference, it has the potential to, pun intended, it has the potential to trigger that circuit. Now I'll show you what it does, what it's like designed to do. So what I'm gonna do is, like, for instance, touch channel 3. I don't have anything hooked up to channel 3, only channel 1 is my camera. So if I connect it, again, it's just doing that dead on off thing. But if I put power to channel 3, you know, this is basically simulating, you probably can't see the light on the test light, but this is simulating, you know, if this were hooked up to some 12-volt wire coming from, you know, your transmission that, you know, puts 12 volts out when you're in reverse, you know, that's the intent of this, obviously, is to trigger this thing, turn this thing on when, you know, here's channel 2, so it'll switch over to channel 2. Again, there's nothing there. And then I can also trigger channel 1, which channel 1 just kind of like defaults on all the time, which that's what the manual says. The manual says hook up channel 1 if you just want it on all the time. But what they don't tell you is that that has a trigger too. But in any case, for some reason, the buttons don't work anymore. They just don't do anything. I have tried pulling all 3 of these to ground, you know, pull it low just to not be in triggering mode. This thing is, you know, when I first got it, you could, you know, mess with the buttons and have it do stuff, you know? You can change the channels, you could, you know, turn the brightness up or down, you know, there's some settings. Now, I'm not really that worried about having the settings, but it's perplexing, you know, that like all of a sudden nothing gets these buttons to work anymore. In the long run, or not in the long run, but like what I'm gonna do here is I'll probably rewire these trigger wires. I'll repin my plug that puts switched power to the camera, and I'll pull trigger 1 high and the other 2 to ground, just to definitively say, you know, camera 1 is on all the time, and it'll just be on all the time whenever the switch is on, which is what I want anyway. All right, so I think I'm gonna wire this back up. I'm gonna attempt 100 on this thing. Wire this back up, repin this, pulling, trigger 1 high all the time, the other 2 to ground, and it'll just be on all the time. We'll try that. If that doesn't work, then I'm gonna throw this thing in the trash. All right, so there it is, all buttoned back up. So I'm gonna lay it right down there for you. So there it is, all buttoned back up with the rewired trigger and ground, with the rewired trigger wires. And as we can see, turns back on for now. We'll see how long it lasts. I'll take it for another test drive later today and we'll see if it stays on. All right, so just finished a test drive, and I took the GoPro on my head that time, so you should be seeing some footage now of me driving it around a little bit. As you can see, the backup camera never shut off, so this is the first time that it went an engine cycle running basically without that camera shutting off. So I think we might have gotten to the bottom of it this time. It probably doesn't need that buck boost converter, but I was playing around with my DC power supply and it does shut off down in kind of like the 9-8 volt region. So it's not going to hurt it to have that on there, and it's kind of, as we can see, it's kind of sensitive. So I'm going to leave the boost buck converter in there. If you're having problems with your backup camera, that may or may not solve your problem, as it was the case here. But now you know what that device is, and you know, if you need to smooth out DC voltages, that's a useful tool to have. I wish some of these electronics would come with better instructions, because the instructions didn't say anything about, you know, there's half-assed instructions that didn't even have the right wiring harness for the instructions. It was wrong colored wires and everything, so you kind of just have to figure it out. And that turned out to be the case here. Those trigger wires, you know, seem to float instead of them pulling it up or down with pull up or down resistors. But they don't say anything about needing to hook it up one way or the other. So I don't know, we'll see. It did good this time. We'll see if it hangs on and keeps working. If not, I'll just find a better one. Probably watch me drive around wondering what the hell I was doing at times. I'm still bedding in the brakes, and you know, I was slamming on the brakes to get the brakes heated up and working good. I made some adjustments to the pedal, bled the brakes again, and the brakes are getting better. They're feeling better now. I think they're starting to bed in. Backup camera's actually working. They're still not ideal, but it's getting better. And then anything else I was doing, I was trying to get some steady state data driving around at, you know, medium RPM to get some data for tuning. So I'm doing that also. So that's what that drive, you know, that's what I was doing on that drive. All right, so it's like 1,000,000 degrees out here. I'm hot. I think that'll do it for this video. Hopefully the backup camera's fixed. It seems to be doing better now. If you stuck around this long, thanks for watching.